Thank you. We are Andrew, Daniel, and François from the Safe Drinking Water Project. We are a data science project and one of the first purely data science project at Code for Boston. So we thought that tonight we will talk about our challenges and our lessons learned during this process. So we are a civic data science project. So what is that, or what do we do? Usually civic partners, they think we build dashboards and we drew pretty maps, and the volunteers that come on Tuesday to the hack night, they come because they want to do social good, because they want to learn by by being in a project, and sometimes they come because they want to apply cutting edge deep learning networks. And but what usually we really do is clean data and do research. And so we have these various stakeholders that have various expectations, and we must find the way, or our way, to go with these needs. And we started with the idea that we want to predict contamination of the drinking water in the US public water systems. The contamination could be because there are pesticides in the drinking water, or lead, or bacteria. And we based our models on public open data, mainly data from the Environmental Protection Agency. And on the right, you see sort of our vision that was, or that is, that's the map of, that's an example, it's a map of the map of all public water system in the DC area. And for each of these water system, we would like to be able to predict with a certain probability what is the probability that they will see a violation or contamination of their drinking water next year. And when you go to this process, one of the largest steps of any data science project is data preparation and data understanding. And data cleaning is pretty boring. So it's a challenge to motivate volunteers to clean data, because they would rather, or we would rather, build machine learning algorithms. Another challenge is the science part in data science. So you need to do a lot of research in order to understand the domain and the data and the issues. And this sort of can be a difference with more traditional software development projects. And there, it was a challenge for us to document and transmit this accumulated knowledge, especially at Code for Boston, which we are volunteer-based, and the volunteers come and go. And that's one of our lessons learned, to spend more time defining this documentation process for the research phase, especially because the traditional tools and processes in software development are not always useful. So after all this time, you can try several models and evaluate them, and that's when reality hits here.
So one of the things that we realized was, so some background, this project is kind of a little bit more unique at Code for Boston, because a lot of projects start with the stakeholder interest, and then they try to find one of their problems and then deploy the right people to solve it. This project was kind of started with the idea that we needed a data science project, so we kind of looked for data science problems to solve. So I think that kind of led us to maybe not be asking the right questions, and maybe needing to take a step back, which is what we've done over the last few months. So we've been looking a lot these days at talking just to a lot of local partners. Turns out in Boston, a very large city with a lot of universities, there are so many groups of people at universities and nonprofits and all that who are just researching the weirdest things. Like you could, not to say that this is weird, but just all sorts of people doing all sorts of things, and we were able to find quite a few local partners over the last few months, and we talked to them about what their needs are, and a lot of those needs are related to data. And we've been, so going forward in 2020, we're going to be working with hopefully at least one of those, definitely at least one of those partners. We're definitely already established that, and potentially even more partners around, the name might have to change. It's not necessarily all drinking water, some of it's surface water as well, but definitely kept to our water approach. So yeah, we definitely learned to spend more time on finding the right research question. So yeah, sorry, it's been a while since I've seen these slides. The data science process seems fastidious and uncertain. That is also what makes it attractive. We did have a lot of volunteers who got a lot out of this. We had, some people learned their first time doing logistic regression. First time, I got one person who did a GitHub pull request for the first time. It was, I tricked him into writing documentation and he gave me a high five. It was awesome. He was really excited. He initiated the high five, not me. So we've had people who learned a lot with R and Python and working with messy data. It's all a lot of fun. And now we get to do it with a nonprofit stakeholder, and that's where it gets really fun. So yeah, if you want to get involved with some of the stuff we have coming up, learn about all the fun things we've learned over the past year, you can find us on our Slack channel at Water. And I believe that's it.
Questions? You can take one or two quick if you want.
Any questions?
So like what properties of surface and groundwater are you looking at?
Repeat the question.
So for our live stream, the question is, what properties of groundwater and surface water are we looking at? So with our new partnerships with like the Charles River Watershed Association, for example, they will go out there and have sort of citizen science-based data sampling of the water resources themselves. So they're looking at like nitrogen loads, phosphorus loads, sort of whether there's algae blooms, other simple things like turbidity, color. In terms of the first phase of this work, in terms of the exploratory data analysis that we've done, we used an EPA data set called SIDWIS, the Safe Drinking Water Information System, for those of you who are curious about your own drinking water. And that doesn't provide a lot of features about specifically groundwater and surface water, aside from whether a public water system gets its water supply from a groundwater or surface water source. Yeah. Go ahead.
The data associated with this project, are you planning on sort of matching it to topological information about runoff as well as distribution and how different problems may sort of push further down the cycles?
Yeah, that's a great question. I would say we've talked a lot about it. So it also presents a lot of interesting challenges, like in terms of jurisdictions and who oversees what water supplies, who owns what water systems and water supplies. But ultimately, I've sort of consulted with a few experts. Sort of the more granular you get with the hydrogeology, it gets very complex very quickly. And so we backed away from that a little bit, although we did look a little bit at like precipitation data, trying to model a little bit on that, because the precipitation data has a strong association with other kinds of like nitrogen contamination and like in Everett over here, right? Whenever it rains, all of the chemical runoff from on top of those oil tanks flushes into the Mystic River, that kind of stuff. Other things you've mentioned about that? Other questions? Maybe one more? People ready to eat more snacks, perhaps? Okay. Thank you so much. Oh, wait, one more. Whoa. Ho, ho, ho! Yeah. Oh, I'll take one. Yeah.
I could ask the question of so as you focused on kind of getting new partners and you've gone through a lot of the exploratory data analysis, what are some of the big questions that you're really looking at?
It's a good question.
So the stakeholders all the stakeholders have very different interests. One of them runs a website that a lot of boaters use, for example, and whether or not the water is safe to, boat in or swim in, stuff like that is really important. Some of that infrastructure is broken, and that's like a website design thing, so we're gonna look around for some website expertise. We're also doing a lot of, they maintain a gigantic data set of all the samples that people manually pull. We're gonna be cleaning that. The PFAS project, we're not officially partnered with them yet, but we're gonna actually be talking to them on Thursday, and they seem very interested in a lot of, which is an emerging contaminant that's in your water. If you have a Teflon pan, it was made with PFAS, and a lot of that gets in the water, and people are unsure about it, and there's a whole lot of questions related to that, and we're looking into a lot of that type of stuff, and it's all data related. It's all very different. It's all different parts of the data process. There's some visualization involved, some data pipeline cleaning, some data science and machine learning stuff. It's all the different parts, and yeah.